doing is I'm going to have like a normal distribution over here. Let's say this is like the math portion of the SAT. And you'd have an average of let's say 490. And you'd have a certain standard deviation. Let's say standard deviation is 40. And then I take the English portion of the SAT. And that might be the average is 500 and your standard deviation is 50. I'm going to add those up and get a new distribution. What do you think the mean of the new distribution would be? Yes. Shut up, Kyle. So this is like your math average score is 490. This is all the people that take the SAT. The English average score is 500. What would you expect the average overall, if I added those two together, to be? It's going to be 990. The averages work just like you would expect them to work. So your average here would be 990. The standard deviation is what this lesson is about. So you cannot add standard deviations. You can only add variances. So first we got to remember that, how do we get from standard deviation to variance? If I give you standard deviation is 3, what's the variance? Nope. Nope. Wow, I didn't do a very good job teaching this, I guess.
Well, maybe you did. We went over how to find standard deviation like one day. It was like you find all the points.
Stop talking. Standard deviation is 3, what's variance? Yeah.
Isn't that the square thing?
No. That equation thingy? Good work, Pyle. Anybody? What? Just start guessing. You didn't guess, you just said equation. That's not an equation, actually. It's so much simpler than you guys are making it. Caleb's close. Nope. That's the opposite of that. Standard deviation squared is variance. Please stop talking. I'm starting to get annoyed. Nick, mostly with you. So standard deviation squared is variance. And when you're combining distributions, what you do all of the time is add the variances. So it turns into like a Pythagorean theorem type of thing. So if I look at this first example here, just to go through how I got these numbers. This is saying I've got two distributions. The average of the first one's 100. The average of the first one's 200. So when I add them up, the average is 300. That makes total sense, right? 100 plus 200 is 300. These are standard deviations. So we cannot add standard deviations. It doesn't work. You have to add variances. So what we do is we square both of these. So you're kind of looking at it like, I look at it like levels. Like standard deviation is down here in this level. I'm going to square it. That puts it up at this level. So what's 3 squared? 9. What's 4 squared? 16. Add those up. What do you get? Now you square root it, and you go back down to the standard deviation level. So you square everything, get them into variances, add them up, and then square root. That's Pythagorean theorem. That's all that is. So this is like your A and your B is A squared plus B squared equals C squared. And you got to find C. So it's just like a Pythagorean theorem with stats. Yeah. Oh, okay. So like on this next one, I got an average of 10, an average of 15. I'm subtracting. So 10 minus 15 is negative 5. Like that's exactly what you'd expect. Even in a subtraction problem, though, I add variances. So it's always addition. So what's 5 squared? 25. What's 12 squared? 144. If you add those up, you get 169. That's the variance level. How do I get from variance back down to standard deviation? Square root of 169 is 13. All right, fill in these next two. What'd you get? So this one I've got a mean of negative 10 and a mean of 10, and I am adding those up. So you would expect the mean to be 0. Here we got a standard deviation of 6. So when I square that, that gives me a variance of 36. This is a standard deviation of 8. When I square that, it gives me a variance of 64. I add the variances and get 100, so then what's the standard deviation? Should be 10. This one for your mean, 30 minus 20 is 10. And then if you do the Pythagorean theorem, I mean, really, you could just do this and go 8, 12, what's the length of that third side? It's literally Pythagorean theorem. It'd be like 14.4. Questions on those two? All right, so let's start working with it and say we got like a story problem here, and how can I apply that to this? So IQ of adults, 105 is the standard deviation of 15. IQ of teenagers, you guys are dumber, right? 100, 18. So what's the distribution of adult plus teen? Well, that's going to be still approximately normal, because you're adding up two normal distributions. What would the mean of the new standard deviation, or mean of the new distribution be? 205. That's just adding up 100 and 115. Find the standard deviation. I get like 23.43. You guys see how I'm getting that? You with me? Distribution of adult IQ minus teen IQ. Still be approximately normal. What would the mean be? Now the mean would be 5. Because on average, I guess the adult IQ is 5 higher than the... And what about the standard deviation? It's the exact same. Because it doesn't matter if I'm adding or subtracting the distributions, I always add the variances. So if you look up here at variances, I put add, always add. So you're always adding variances, you're never going to subtract. Alright, so then part D, what's the probability that if I add up one of each IQ, I get greater than 220? Well, now I'm going back to this, because this is the one that I got when I added them together. So I basically, this question is just like the warm-up. I've got, this is my mean, this is my standard deviation. What's the probability that I get a number bigger than 220? So it's normal CDF. Bigger than 220 would be what, comma, what? 220, comma, you know, some giant number, whatever that is. What's the mean and standard deviation that I'm going to use? 205 and 23.43, yep. So let's see what that is. So I get like 0.26. So it should be smaller than half, right? Because I'm above the mean. 220 is bigger than the mean, and I'm already above the mean, and I'm looking up. So it's going to be less than 50%. How many got 0.26 there? All right, E is the hard one. So E is the one where usually people are like, yeah, this is fine, this is great, this is easy. What the hell is this? So E is the what the hell is going on. So what's the probability a randomly selected adult has a greater IQ than a randomly selected teen? Well, if I want to look at two IQ, okay, 120 and 130, which one's bigger? Why? Why? How do you know that? You can't say because counting. What? If I want to know X, if I just have X and Y, and I want to know which one's bigger, what would I do?
I don't know.
Yeah. No. All right, let me help you more. X and Y are two numbers. I don't know what they are, but I know when I do X minus Y, I get a positive number. Which one's bigger? X. Okay, so why is 130 bigger than 120? Because when you subtract, what kind of number do you get? Positive number. All right. So the way I know you could just look at it and be like, well, that's bigger, idiot. What are you talking about? But if I want to compare two numbers and I subtract and then it comes out positive, the first number is bigger. If I subtract and it comes out negative, the first number is small. Does that make sense? Okay, so that's what I'm going to use here. If the adult has a greater IQ than the teen, then I want adult minus teen to be what? Needs to be positive. Well, this was adult minus teen. This is the distribution right here. I want that to be a positive number. What numbers are positive? Between what and what? Between 0 and 9999 or infinity, right? So, I'm going to go normal CDF from 0 to 999 of the adult minus the teen, which gave me 5 and 23.43. Now, should my answer be bigger than 50% or smaller than 50%? The adult average is higher. So is it true that usually the adult is smarter or usually the adult is dumber? Usually the adult is smarter. So when I'm finding out when the adult is smarter, should this be bigger than 50% or lower? It should be bigger. If you get a smaller number, all you did was reverse it. So you could so if you did this backwards, you'd get like 0.4. Let's do it. Hold on. Let me find the number first. So I get 0.58. If you did it backwards, you'd get 0.42, at which point you would hopefully realize, wait, it's supposed to be more than half. So the more than half version of 0.42 is 0.58. Does that make any sense? So instead of being like 8% below the middle, you just flip it and you make it 8% above. If you do it right, you're going to be fine. But if you do it wrong, all that happens is it's just the opposite. It's like the complement of what you're looking for. Questions on this one? Yeah.
Can you explain why you use 5 and not 205?
Because when I'm comparing to see who is bigger, I'm not adding the two things together. I'm subtracting to see if it's positive or negative. So then there's the two choices up here, right? We got where we added it and where we subtracted it. Because I'm comparing two numbers, I use the one we subtracted. Your hand was up too. Wasn't it? No? Okay. Okay. Other questions? All right, let's go to the next one. So this one even gets goofier because time, if I'm going to win a race, should my time be lower or higher? Should be lower. So this gets even a little more confusing because I have to do that. Let's do this part first. Like part B first because it's easier. I'm going to combine the times. It means I'm going to add them. So I got these two distributions up here that I want to add up. You don't have to show this thing I'm writing now. I'm just doing it to like help you see what's happening. What would you expect our combined time to be? Like what's the average of the new distribution? should be 17.5. That's just combining the average of my mile time and the average of Gillis' mile time. Add them up. Go ahead and find the standard deviation. I got 0.8. You guys agree?
Yes.
So that's just the Pythagorean theorem thing. Now I want to know less than 17 minutes. So from what to what if I want to know less than 17? 17 at the top. What's the bottom? Like negative something really negative. And then I tell the calculator the mean. Tell the calculator the standard deviation. It's hard for me to tell right now if you guys are understanding what I'm doing. You are? Okay. So for this one I get 0.266, let's say. So that makes sense. If my mile time is slower, I shouldn't beat him very often. So just, you always want to check your answers and make sure they make sense with what's going on. If I got to like 0.7 here, like I average a slower mile time, but I beat him usually, that doesn't make any sense. So you got to wrap your brain around like what's supposed to be happening. What? Oh, right, yeah, sorry, okay. So, but the same idea, like I'm supposed to be 17.5, I'm asking for lower than that, so it should be less than half. Alright, top one. We can, if I'm going to see whose time is, I want to compare the times, not add them up. I want to compare the times. Am I adding or subtracting? I'm subtracting. You can subtract either order you want. You can do Davis minus Gillis. You can do Gillis minus Davis. What happens after that will be different depending on what you put. So if you want to just do it the way I'm doing it, that's cool. If you want to try it the other way, you can, but it's going to look a little different. So I'm going to do Gillis minus Davis. So I'm doing approximately normal 8.5, comma 0.7, minus approximately normal 9, comma 0.4. What would the mean of the new distribution be? Same as what? I think you're thinking of standard deviation, actually. So the standard deviation is going to be the same. It's still 0.8. What's the mean? Negative 0.5, because 8.5 minus 9. Now, if I beat him, is Gillis minus, remember if I beat him, it's a lower time. Like I got to the finish line faster, so the time is smaller. If I win the race, is Gillis minus Davis positive or negative? It would be positive. So like, let's say it takes me 6 minutes, and it takes him 8. That means I won the race, right? So an 8 minus 6 is a positive number. So if I win the race, it's a positive number. Should I win the race more than half the time or less than half the time? I should win less because his average time is lower than mine. So I shouldn't win very often. So keep that in mind when you get your answer, because if you get an answer where I win more than half, you did it backwards. So I'm going to do normal CDF. And again, if Davis wins the race, when I subtract, do I get a positive or negative number? Positive. What are positive numbers? Between what and what? 0 and 99999. What's the mean? Negative 0.5. What's the standard deviation? 0.8. So you've got this distribution where the middle is negative 0.5, and I'm looking for this part. So it's got to be more than, wait, no, 0's on the other side. So it's got to be less than half. Someone say it's the same answer. Is Is it really? Yeah. I mean, it makes sense because we're like 0.5 away from the middle in both, but it's not going to happen every time because it won't always be the same setup. Question on that one? Yeah. I could have chosen either way. So the difference is, don't put your stuff away, please. The difference is if I did Davis minus Gillis, now if I win the race, it's negative. You don't need to understand both. You just pick one and like logic your way through that one, and we'll practice more, but you just got to pick one. So once I've picked this, then that like determines everything else. If you pick backwards, if you get it backwards, what would happen is you'd get 0.734. Hopefully at that point you'd be like, well wait, Davis isn't usually supposed to win. So I'm going to do 1 minus that, and that'll be my answer. So if you're wrong, you can correct it because you'll realize you're wrong. Hopefully. Does that help some? I mean, we'll do more Monday. All right. Yeah, right. Both. I don't know where I said it, but it's true in both.
On Wednesday, about the fact that I heard you talking crap about it.
What?
Yeah. What's up?
No, just in case I don't get any of the answers today.
Alright.
Also, is this Caleb in your charge here? Oh,
When you guys were last in the test, you're like,
Why do you have hate on my 4th hour? Not everything.
we tried. There's 8 of you trying to move it up. It was tonight. So you can get a hand. What happens if they're bad? I'm gonna have. You got circle things. What is it?
Yeah, it just looks painful.
I'm saving. Let's see, Drew is Steven. I don't know, just even know. Hold on. You're right, so.
Really.